Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to talk about the discriminant from the quadratic formula. We're going to evaluate the discriminant for several equations, and then we're going to use that discriminant to figure out how many solutions we have and what type they are. So first, the discriminant is b squared minus 4ac. It's the part underneath the square root in the quadratic formula. And the sign of that expression is really important because if you remember inside the formula, that is the part that's underneath the square root, what we call the radicand. And if that is negative, that means that the square root is going to turn into an imaginary number, which gives us complex solutions. If that number is 0, the square root of 0 is 0, that disappears, and it only leaves us with the negative b over 2a, which is a single real solution. If that number is positive, we're going to get two real solutions because the square root of a positive number is a real number. If that happens to be a perfect square that we can take the square root of, then we're going to get two what we would call rational solutions. So let's summarize this. If b squared minus 4ac is less than 0, we get two complex, or what we would call non-real solutions. If it equals 0, we get one single real root or solution. If it's greater than 0, we get two real solutions. And if it happens to be a perfect square, positive perfect square, that means we're going to get two rational solutions. And rational just means that we can express it as a fraction of an integer over another integer. All right, let's take a look at these four. First, we've got x squared plus 4x minus 10 equals 0. A is 1, b is 4, c is negative 10. So the discriminant, b squared minus 4ac, that's 4 squared minus 4 times 1 times negative 10. That is 16 plus 40, or 56. So it's positive, but we don't know the square root of 56. So that tells us that there's going to be two real solutions. We don't know that they're rational because the square root of 56, although we can factor that sum, we would still end up with 2 square root of 14. When you have a square root, it's not rational. 15, 9x squared plus 30x plus 25. B squared minus 4ac this time is going to be 30 squared minus 4 times 9 times 25. 30 squared is 900. Minus 4 times 9 times 25, that's also 900. You can do that in your head by multiplying 4 times 25. We know that 4 quarters equals $1. 4 times 25 is 100, times 9 is 900. So we've got 900 minus 900, or 0. That means, looking back to the quadratic formula at the top left, when that discriminant is 0, this piece disappears, and you're just left with negative b over 2a, a single real solution. One real solution. Let's continue on. Number 16, b squared minus 4ac is going to be negative 19 squared minus 4 times 6 times 10. Negative 19 squared is the same as 19 squared. Right? When we square a negative number, it becomes positive. That equals 361. Minus 4 times 6 times 10, that equals 240. 361 minus 240 equals 121. that is a perfect square. Square root of 121 is 11. So going back to the quadratic formula one more time, that means that this would get replaced by the number 11. And we could take the opposite of b, plus or minus 11, and get single numbers out of those, divide by the denominator. We've got a fraction. This is, when that's the case, that means that we have two rational real roots. For the last one, 2x squared plus 5x plus 20 equals 0. B squared minus 4ac is going to be 5 squared minus 4 times 2 times 20. That gets us 25 minus 160, or negative 135. Because that is negative, we would be taking the square root of a negative number, and that means that we get two complex, non-real solutions. And by the way, we have to say non-real because all of these numbers, whether they're what we've been calling real numbers, imaginary, they're all subsets of the complex numbers. So just saying that they're complex is not enough. We have to say that they're not real. All right, that ends this section. I'll see you on the next section.